Hello, everybody. It's Mark Kelly here. I'd like to welcome you all to the AI in Action virtual meetup. We've got a fantastic lineup today, and I'm really looking forward to sharing more information about it. We've got Alexandra Seiffermann at CrystalsFirst. We have Eoghan Mulcahy and Ciaran O'Mara from Deepseek.ai. And finally, we've got Milton Luaces from FTI Consulting. They'll be giving a variety of overview about the industry, and specifically, Alexandra will talk about AI implementation within biotech. Eoghan and Ciaran will talk about their PhD research of deep learning being applied in the real world. Milton Luaces will give us an overview about his recent experience working in Accenture and recently becoming the new Managing Director of Data Science at FTI Consulting. Milton will give us an overview about his experience working at FTI Consulting and some of the problems that they solved there, and later we'll be able to ask the guests some questions as well. I'm a little bit about myself. I'm the founder of AI Ireland and also the AI Awards. And day to day, I'm an executive search consultant at Alldus International. At Alldus, we're a specialist data science and AI recruitment company servicing Europe and the US. And we set up Alldus to be a community-driven initiative to really drive forward AI while making sure that we are best in class in recruiting and helping people further their career in this field. At Alldus, we're ambitious, we've got listeners, we're learners, we've got drive, and we're unified, and most of all, we're specialists. And we've got two central hubs. One is in Brooklyn, the next is in Smithfield, where we service our European operations. And from our Brooklyn hub, we service our US operations. Before COVID, we were doing meetups in person across Berlin and Dublin the first Wednesday of every month. And since COVID, we've now been doing virtual meetups. They usually happen twice every 6 weeks. Virtual meetups can be AI in healthcare. It could be other industries where we're applying AI to solving different business problems or societal problems. We also go on the technology routes, such as NLP or computer vision across different industries. And really what we're looking to do is share people's practices and experiences so other people can grow from them. Within our meetups, we've got a variety of different members. Below is a little bit of a breakdown of those members and how they actually break down. There's also some past speakers there to give you an idea of some of the speakers that have spoken at our meetups and also our virtual meetups, and they're available on alldus.com if you ever want to reach out and see some of the content there as well. We also have two podcast series, and in the two podcast series, we look to share people's insights and experience. Our first podcast is called AI in Action, and AI in Action talks about the applications and ramifications of applying machine learning to solving business problems, where people will come on and share about what their companies are doing to apply machine learning to solving business problems that actually increase and give a better customer experience internally and also externally. With our AI Mentors podcast, we talk about how you can scale and grow and build a data science machine learning team, some of the things to take into consideration, and how do you actually manage research to ensure you generate return on investment from the work that you actually do. And people offer advice on how to propel your career in the world of data science and machine learning. We have over 200 podcast episodes now at alldus.com, but you can listen to the podcast series on whatever platform you choose, such as Stitcher, Spotify, Apple Podcasts, you name it, you'll find it there. We're one of the most trusted recruitment agencies in Europe. We've got over 300 five-star Google reviews, and we're really, really proud of the fact that we're actually adding a lot of value to the candidates and clients that we're working with day to day, and also really adding a lot of value from the community initiatives that we do. But we don't take this for granted, so we're always looking for people to get involved with our community initiatives, either as a speaker or if you want to add some information in terms of career advice or experience that you'd love to have known when you were younger. We'd love to share that on our website as well. On our website, you'll be able to find the latest roles within data science and machine learning, podcasts, our virtual meetups, as mentioned before, but also interview techniques, career advice, and some blogs from guest posts from people sharing it on the alldus.com website too. But if you ever want to feel free to reach out to me at mark@alldus.com, and I'll share more information if you require that too. Our next guest is Alexandra Seiffermann, and Alexandra is going to speak about AI implementations in biotech startups and some of the research that she did while she was working for CrystalsFirst. Alexandra. Great to have you on the show today.
Thank you, Mark. So welcome to my presentation on AI implementation in biotech startups. A bit about me. As you know, my name is Alexandra Seiffermann, and I did my bachelor's in biology in Marburg. Then I took part in IGEM, which really woke my interest in science beyond just work at the bench. So I did an internship in business development at CrystalsFirst, and where I learned so much about what's going on in biotech now and all the cool new tools like AI. So during my master's in Warwick in medical biotech and business management, I did this thesis. During my dissertation, I explored how to build and grow a startup that uses AI to conduct pharmaceutical R&D, so to create medicine. And to this end, I talked to 6 experts from very different companies that use AI tools also for different things, who are either the founders or key players in these companies. And I found some important factors to really maximize the growth of something like this. So the trends that were recognized by the interviewees that have an impact on their companies regarding AI is the rise in scientific data available. There's simply so much being uploaded that it's impossible to have all the data you need to make informed decisions. And there's a continuous decrease in the return on investment in big pharma. So there's a problem there to be solved. They think that AI will continue to trend and that skepticism continues to wane. They see that there are more funds available every year. There are more advancements being made in machine learning, especially some that are open source, so everyone can take part and use them. And there are more partners reaching out to them who want to work with startups using these new tools. But it's very important to keep expectations realistic. Customers need to know that AI is not a terminator, but it's also not a miracle worker. It's just a tool, and its reputation really needs to be managed. The key findings around acquiring data was that you can, of course, train your AI on public data. Usually you have to at first because it's free and it's in very high volume. But there is no quality control and it's available to all. So small mistakes go completely unnoticed a lot of the time, and they can have huge repercussions for your data set. And they're available to everyone. And every interviewee said it's very important for your customers that you have unique solutions. So having data that everyone else has will not really lead to those unique solutions. Public data seems all right to train on an AI on text data, but it might be too complex for structural data, or structural data is too complex, so a mistake can have big repercussions. You can also acquire data to outsourcing with clients, where your work is rewarded, you're being paid, the volume is variable, but it is high quality and proprietary. Some said that this data can only be used to improve the AI for in-house use, for your own pipeline, because they do not want their competitors to also have a better AI and better results because of their labor. You can outsource data through a CRO, which is expensive, and usually you get a low volume of data, but it is high quality, and that seems to correlate to how expensive the data is. When you're outsourcing through a CRO, you are investing in someone else's company. You can also acquire data through partnerships, for example, with academia, where your data is free, but it's usually in a low volume, but it's very high quality because the data has been analyzed from multiple different angles from someone who is well trained. And this is a low competition setting. What that means is you are not competing with people in academia. Actually, you're building a bridge, for example, by giving someone a place to do their master thesis. They might join your company later. You're building a relationship with very scarce talent. But this isn't very scalable. You need to put in a lot of energy to create these partnerships with academia. You could also partner with other startups. The price is negotiable. It could result in a high volume of data. It could be high quality if they're using a new tool. You aren't really sure yet. But it could also be competitive. I heard a lot of people don't know who they're really dealing with. And so there's really a lot of uncertainty around partnering with other startups. The data strategy I saw the most was starting on public data and then supplementing it with high quality academic or client partnerships. And a different strategy, which seems to have really good results, is having your own in-house lab. This means a high initial investment, but it's set to save costs in the long run. And all your resources are going into building your own company. So even if the AI aspect doesn't work, you still build a really good lab with good staff that works right. Your data is high quality, proprietary, and in high volume. No one else has access to this data, so you're definitely improving your AI in a different direction than other people. And that's also very valuable. It contributes to the culture and it attracts talents in all fields, and I'll talk more about that later. So the key findings surrounding tech were: number one, start on that free cloud computing, make use of what you can get. Number two, invest on those in-house servers for the baseline of your work as soon as it's stable, because it will save money in the long run. And a lot of people said they regretted starting that so late, having in-house servers. And number three, stay flexible. If you need to, go into the cloud, take every opportunity, and make sure to continuously rebuild your AI. There's so much available, also open source, that you can just try out new things. And that seems to be really the recipe of success, is constantly iterating your AI, changing it, putting in new data, but also trying out new things outside of what you're doing, just to see maybe it'll help you, maybe it'll improve your quality a bit. And number four, avoid the black box, because it hinders communication between the AI specialists and the scientists creating the data. And I'll talk more about this now because it seems to be the main issue in this type of company. You have biologists and chemists that really understand the disease. They know the drug development process, so they understand how their data is being used and their experience in the experiments that create the data. So they know how the data is created, what values have a lot of meaning, and what values are just some type of change you see from one day to the other that doesn't really have a lot of meaning. AI specialists do not really grasp these nuances of the data fully because they haven't worked with it themselves, and they're very expensive to recruit. And there is a very big shortage of people who are specialists in the drug development side and the AI side, and they're even more expensive to recruit. So to bridge this gap between the two groups, you could do it through learning. This means open offices, which encourage discussion and learning. People talk to each other, ask what they're doing, just day to day, keep learning by talking to each other. And it also breeds a lot of appreciation for each other's work, and not just, why is this tool not working? They don't understand what they're doing. This way you can really see the process and understand how much work goes into it. Also offering to pay for online courses that build their education within topics that are interesting for the company is very, very valuable. And having talks involving the whole team, not just a part of it, everyone involved. They can be weekly or daily, depending on the size of the team. And it's important that both parts of the team, so AI and drug development, explain their approach to the project. If they're talking about what they're doing, it's really good because you avoid those miscommunications where you don't really know how the data is being used, how the tool should be used. You're saving time and frustration for your customer. Members from each area of expertise can also do weekly presentations about basics in their field and current breakthroughs, as well as their background. This means everyone on the team knows, they're being educated on the fields. They know about current breakthroughs, and so they have ideas on how they could be used within the company with their data. And they know who to reach out to if they have an idea, because they know the background and the expertise of people on the team. So this picture is meant to show you again how the AI area specialists and the drug development area specialists, through communication, those one-way talks, the project discussions, and the open offices, get a very deep understanding of the data that just isn't possible if they're separated, which results in a very good AI tool. But it's also about recruiting the right people for your team. So you need some people who manage both fields that also understand both fields. So they can always almost like speak the same language. A lot of times, these are actually the founders of the company. And then only when the company really grows and they have more funds can they onboard these people who are really, really important for the team. And yeah, they basically build the bridge between the two groups, but that takes time. So while you can't do that, that communication is super, super valuable. The drug development specialists need the PhD, they needed the experience. It was said that drug development is an art form, so having experience is very valuable. On the AI side, they're already so expensive, especially for a small team, that having people who are not as educated is fine. This is something where opinions were very different. But having people who are not as educated, because the field is changing so much as well, it's more important that they understand your data, they have some experience, but then they have to be very motivated. They want to keep up to date, they want to read a lot, learn a lot of new things. They come back from the weekend, they have a new idea for your AI because they read a paper. Those are the most important people, not AI specialists who have a PhD, because it's good if they're flexible. That means they're taking on all of the new updates in the field as they come out. So recruiting these AI specialists, one thing to keep in mind is a high salary is a given in this field, but the main motivators to have AI specialists join another field, in a biotech company working for something that is for R&D, is playing a role in saving lives, people who are motivated by doing something for the greater good, people who want to do something cool, edgy, being part of a trendy movement is also appealing, and continuing to explore and develop tech. I talked to a lot of people who actually loved academia and but they were frustrated by how slow the whole process of coming up with an idea and bringing it to people was. So people who actually love academia, but are almost too motivated for it because they want to do something right now, are great fits for this type of company. You can find the AI specialists by moving closer to talent hubs like Silicon Valley or universities. You can build your talent flexibly through partnerships with academia and hire them once you have the funds. This means, for example, you let someone do their master thesis with you, but you're a very small company. So at the end of the project, you actually don't know if you'll have the funds to hire them right away or to keep them on board. So this way you have another coworker, and while they're working for you, you're building the company and probably getting more stable so that you can actually hire them. Another very powerful thing to get AI specialists is having an in-house lab. It creates a very unique opportunity for these specialists to influence science, and it really sets you apart from Google or Amazon. Because if you just say, oh, we use this for R&D, that's one thing. But if you say there are people in the lab waiting for your results, you're just influencing the experiments of chemists and biologists. That is something that AI specialists don't usually hear, and it's very special. So if you're a startup in this field, there are some positive aspects and some negative ones. But we see there are a lot of startups who are making so much headway, and they're really the innovators right now. And the reasons are they can innovate freely and communicate really efficiently. In a big company, you would have to ask your boss and your boss's boss if you can do something that probably won't work for 4 days, for just a short amount of time. And until that decision has been made, those 4 days have already passed, everything is much slower. In a startup, you just trust each other, or you talk with two people, it's a very short conversation. You get everyone on board and you can just go forward with really risky ideas, and you're not working against anyone. Startups also create an atmosphere of motivation, because if a startup isn't successful, it will simply cease to exist. And you get free services to help you grow, like access to cloud computing. On the negative side, there is a huge lack of high quality scientific data. All the companies complain about this. but it's something you can build up to, especially through partnerships, clients, of course, and having your own lab. There's also very high pressure. So the negative side of creating that atmosphere of motivation is that I heard the word burnout a lot. And because they have such motivated employees, they want to do everything. You also need to keep an eye on that work-life balance and not overwork them for your idea. It's important to stay focused on tangible results and not get lost in that cool tech. A lot of companies said it's a big problem in this field because people, can get lost in how they're doing something really new and they have such a clever idea, but is this actually a problem that your customer has? That's something to always keep in mind. And when you're in the bubble of the startup and everyone's like-minded, it can be easy to lose focus. And the last part was that it was hard to find trusted partners, because when you look online, it's a lot of buzzwords and it's hard to find out what each company's value proposition really is, what they're doing, and how these startups could partner up, because they're not really sure who they're talking to. But through meetups like this, people communicate openly, actually say what they're doing clearly, and that really opens up the doors for some really helpful collaboration. So this is improving rapidly. So the general thesis of my thesis is on data, start training on public data. And as soon as you can, supplement it with high quality partner or your own data, even better. On tech, keep improving the AI through this new data. And don't be afraid to continuously rebuild with new advancements in the field. Don't just wait for your own ideas to improve your AI. Take everything you can find online. I even heard from a company that there's no need to do your own AI research almost. You can just keep improving your AI through what's available out there because there's so much being created. On the team, get people who are driven by innovation. They want to stay updated and bridge that divide between the expertise through talks and education. Putting time into this is very valuable and it saves you time and it improves your AI. So even if it seems like you're spending too much time just talking to each other, it saves time. And everyone said they regretted doing less of this. And the one company who didn't, they have had a different growth curve than the ones who did, definitely. Having an in-house lab really helps recruiting that specialized AI talent. Seems to be a huge differentiator. And if you're doing all of these, your company should be evolving at a higher rate. This mind map shows you again how all of these aspects are interconnected. To build this culture of interdisciplinary innovation, it's important to have the team, the motivated people, and being flexible with your tech, keeping up to date. Your team has to have that mindset. And even though your tech has to be flexible, you need to keep in mind that the AI needs to be a tool that fixes real issues. And on the data, move away from public data as soon as possible and create that data in-house, take that risk. It's very innovative, of course, to have both, and not many companies do it, but it's very valuable. And keep improving your data sets and keep improving your AI with new data, but also with the new updates that you find regarding the tech. So a big thank you to CrystalsFirst for the support, for just leading with your vision and giving me this opportunity. If any of the interviewees see this, thank you again for your input. And I hope you can take something from this talk and apply it to your company as well.
Alexandra, thank you very much for that. Loads of food for thought for people to learn from your insights. Was there ever any kind of key areas why projects fail? Because it seems that you need to be doing quite a lot for a project actually to succeed.
Yes. Well, what I saw was that the most important thing was that they weren't just doing their own research, which might work really well for DeepMind, for example, but they were taking everything they were given and using that open sourced, there's so much out there, always reading those papers and improving continuously, even if they didn't have the best communication and they grew slower. That seemed to make a huge difference if they were successful or not.
And knowing everything you know now, if you were to sum up in 1 to 2 statements the advice you'd offer to companies applying AI in whatever industry, what would come to mind?
I think, like with every startup, roll with the punches, stay present and don't be afraid to pivot, have new ideas. And if you notice your product isn't working for the customer, change your product and keep iterating your AI and getting new data.
That's really, really good advice. Alexandra Seiffermann from CrystalsFirst, thank you so much.
Thank you, Mark.
Great. Some absolutely pleasure to introduce our 2 next speakers. We've Eoghan Mulcahy, CEO of Deepseek.ai, and we also have Ciaran O'Mara, CTO of Deepseek.ai, and they're going to speak about deep learning in the real world, understanding public space engagement with an end-to-end data pipeline. And we'll also have some questions for Eoghan and Ciaran at the end of that. I'm going to pass over to yourselves, guys.
Yeah, thanks, Mark. So as you said, we're going to be talking about deep learning in the real world. The specific application we're going to look at is understanding public space engagement, and we're going to use a data pipeline to do so. So as Mark said, my name is Ciaran. I'm the CTO of Deepseek. Eoghan is here as well. He's our CEO. But today we're going to talk with our research caps on. I'm doing a data engineering PhD in UL. I'm in second year.
Yeah, hi everyone. My name is Eoghan, and I'm doing an AI engineering PhD in the University of Limerick as well. And me and Ciaran came together on this project, which is really an all-encompassing project, an end-to-end solution, looking at really deploying production models into the real world. And I'm looking at 2 components of that today. I'm looking at data collection and data distribution.
Thanks, Eoghan. Yeah, so we'll kick straight into it. So I suppose we started this project with a specific, research question. And we really wanted to look at how you can collect actionable insights and how you can do that efficiently. And in doing so, we looked at understanding, as we said, public space engagement. So understanding how our streets are used, keeping pedestrian privacy encompassed in that as well. So why does that specific application even matter? Why does it matter that we should understand how our streets are used? It matters quite a lot, to be honest. So as urban spaces and cities have an influx of people coming to them, they're becoming more populated, more densely populated. And especially around COVID, it's really important to understand how the streets are being used, what works well, what doesn't work, and how it can be improved. So to collect that kind of data, we're proposing a data pipeline. And the data pipeline consists of 4 main sections, and Eoghan will touch on this a bit in the next slide as well. So the first is the data capture. So with any data pipeline, data capture layer is the first thing that comes to mind with it. And this is often something that's overlooked. So how do we get data into our pipeline before we even do any processing? So any kind of sensor that interacts with the real world, it could be in this data capture layer. In this one, we're using a thermal imaging camera. So to keep pedestrian privacy intact, we use a thermal imaging camera. That's piped then into our data processing. This data processing is on the cloud, so there's a network link there. That processing then puts our data into our data collection layer, which is our database, our API, which Eoghan again will speak about later. And then there's some processing done there. So a back and forth feedback loop between processing and collection. And then finally, again, something that's often overlooked is the data distribution. So how do you actually distribute this data and put it in the hands of the stakeholders and those who really need it? So in this case, city planners and also researchers as well, who can come in and look at the data that we've collected. So underpinning this entire pipeline, we've nailed out 5 particular aspects, and there's 2 I want to really focus in on. So the first is the cost effectiveness of this pipeline. So specifically, if this is a cloud-based pipeline, it can often get quite expensive. So we really focus in on how we can build this to be as cost effective as possible. The second then is the solution scalability. So again, coming in with cost effectiveness, if you've a lot of cameras deployed in an urban environment, so for example, in this project, we deployed our cameras in Limerick City. We had quite a number of cameras deployed. So we needed to make sure that our cloud solution was actually scalable and could keep up with the amount of data that was coming in. The next 2 are quite a given for a machine learning project. So looking at accuracy and reliability and data integrity. So touching on reliability there, we needed to make sure that the data that was coming in was reliable, that we were constantly getting it through, and that there was no network outages or anything that could disrupt that flow of data. And finally, again, linking back to data distribution, how can you access that data? So the actual accessibility of that data. So Eoghan is going to touch on the actual application a bit more in the next slide.
Yeah, so Ciaran has really brought us through all the underpinnings of this project. And this system overview just is a highest level of abstraction of what we worked on, just to get everyone on the same page before we dig into the nuts and bolts. So as mentioned, there's three main layers. There's the capture layer, the inference layer, and then the insights layer. So at the capture layer, we used a low resolution thermal camera to stream privacy ensuring data up to our cloud. So on the compute unit, we encoded that data and encrypted it, and then we streamed it up to our AWS services. And the inference layer, we decoded these. So we had a stream of video coming in, and we decoded them into imagery that we could pass to our YOLO v4 object detection model. Once the bounding boxes were generated, we needed to have some post-processing steps. And we also wanted to store this data so that we could improve our models continuously over time. From this detections data, we were able to generate our higher level insights. So our higher level insights would have included the number of people on the street, the speed they moved at, how long they stayed for, and topically due to COVID-19, the distance maintained between groups. So that's looking at social distancing. And when all these high level insights have been generated, we then moved to the insights layer, which was the presentation layer to the stakeholders that Ciaran mentioned. So we had a web app that the public could interface with. And then we also had a REST API and various SDKs so that other researchers could use this data to find more about what was happening in the streets.
So to delve into the data capture layer first, so as I said earlier, there's four particular sections we're going to look at. So the first one is the data capture. So how do we actually get the data from the real world and put it into our data pipeline? So we actually had to build custom hardware to do so. Again, feeding back to the cost effectiveness of the solution, we had to build our own hardware. So the hardware consisted of a few different components. So the first is a compute unit. Off that, then we had our FLIR Lepton 3.5 thermal imaging camera. This is a 160 by 120 pixel camera. We also had some power management. And a big thing for us was that the actual module had to be waterproof and weatherproof. And by doing so, that caused a lot of issues around temperature. So we had to actually install a temperature regulation system with a weatherproof venting system to actually keep the heat of the system down. Before we installed this, the 4G dongle that we're using actually started to reset, and that caused a load of reliability issues. So it was actually important that we got some temperature regulation in there. On the software side, then we used a Docker image, which consisted of a GStreamer piece of code, which allowed us to actually stream the video stream back to up to our cloud backend. So touching on the temperature again, so these are just two cameras we'd installed, Thomas Street and Griffith Row, between the 22nd and 30th of September. So just touching on the temperature cycles here. So again, for cost effectiveness, we only put the cameras on from 9 a.m. in the morning to 9 p.m. at night. So you can see there between the green streaming arrow in the center, that while it's streaming, the temperature spikes, and then when it's not streaming, it doesn't. So with the temperature regulation unit, we managed to get the baseline down to around 35 degrees Celsius. Before the temperature regulation unit, it was up around 87 degrees, which caused significant issues. So these are just, again, a visual of what it actually looked like installed. So on the left is Thomas Street. Thomas Street is quite a busy street inside Limerick City. So we got a nice bit of footfall there. Griffith Row, on the other hand, is a small laneway. And beside it, just there on the right-hand side, you can see there's a cafe shop. So the contrast between the two was quite interesting to look at. So high pedestrian footfall on Thomas Street, again, with some challenges from a pedestrian detection point of view, which I'll touch on later. And then Griffith Row, which had quite a low footfall. But again, that footfall was for that cafe. So this is actually what the images look like. Again, 160 by 120 pixels, quite small. If we blow them up, you can see the kind of resolutions we're looking at. So not great, but also not too bad. And this was a challenge. How can we actually pick out the pedestrians in the frames themselves? So onto that data processing, and this is the next step in the data pipeline. So we had to come up with a data processing, and again, it's a fairly straightforward pipeline. We've person detection first. So looking at pedestrians on the street and actually detecting them. Next, we have storing those detections, so keeping those stored. Onto the tracking algorithm then, which we use a simple online real-time tracking, a sort algorithm, and a feedback loop here then. So we use our detection stores to actually store detections of people and also store the trails or the tracking trails of those people. Finally, then on to the insights generation, and finally the insights store, which Owen touched on the application slide he went through. So before we went into deep learning, into a deep learning approach, we actually looked at some classical computer visioning and machine learning approaches to actually do this. So we looked at thresholding and we looked at background subtraction. But what we found was that the scene was so varied that we could not get it to work reliably. So we settled for a deep learning approach. We chose the YOLO V4 architecture, which is the real-time object recognition system, quite common object detection architecture. And then we took an open data set from FLIR. So FLIR have an open 640 by 512 data set. It's supposed to be used for autonomous driving, but in this case we used it for our project and it worked fairly nicely. So you can see there on the left the annotated bounding boxes. On the right you can see the kind of quality of the data set. It's quite high quality. So we had to scale this back down. So oftentimes you're looking for higher quality data. In this case, we were actually looking for worse quality because we were transfer learning YOLO, the out of the box YOLO, to try and transfer learn it so that it would work with our camera. And for this, we had to downscale the resolution of the FLIR data set, and we got something like on the left there, as you can see. In terms of fine tuning, then we got some pretty nice results. So we had a baseline model, which was the YOLO out of the box trained on the COCO dataset. We then had a V1 version of the model, which was trained on the FLIR dataset. And then finally V2, which was trained on a subset of our Griffith row imagery. So we were able to actually store that imagery and query it to generate our own annotated dataset. So we looked at two main things. So we looked at map at 50, but we also looked at precision and recall, two of the main kind of, I suppose, metrics that you use for object detection. So precision looks at true positives and false positives. So out of the true positive and false positive, how many true positives do you pick out? But what we were really interested in was recall. So out of all the people in the frame, how many true positives do you pick out? So how many people do you actually pick out? And in our deployment results, we got some, again, nice results. So V2, which was the deployment model that we actually used. For recall on the instances, we came in there around 82%. And for recall on actually crossing the line, so actually counting people. So the instances is actually picking people up in an instance of a frame, and crossing the line is actually picking that person up over a period of maybe 3 seconds as they walk through the frame and as they cross the line. So this is actually what it looked like to kind of visualize it. So on the left there, you see Thomas Street, and it has direct sunlight. So one of the other issues that we came up against was that the sunlight on the street actually really affected the natural segmentation between pedestrians and the background. So there on the left, you can see that it actually misses someone up the top left of the image. In the middle, we've a lot better natural segmentation, but in the middle of the frame, you can see there's actually 3 people walking and the model only picks 2 up. So there's a few things that still can be worked on. And on the right there, you see Griffith Road, just people social distancing and queuing up for the cafe. In terms of actually getting some information and some kind of, I suppose, metrics out of the imagery, we used what's called a bird's eye transform. And this is on a paper written back in 2010. They used this kind of a perspective, kind of a bird's eye view virtual camera to see how to kind of project a projection of an autonomous driving vehicle, and we ported this to the application of pedestrians on a street, and it worked quite well. So it essentially takes your height and angle of the camera that you have, and you can actually project what your camera sees into kind of a bird's eye virtual view. So this is how it looks like in practice. The left-hand side here, you can see people walking around in one of our test images or test videos. And on the right, you can see it actually projects those coordinates of the people into the 2D kind of a bird's eye transformation, and works quite well for social distancing. So actually figuring out how far away people are from each other. In terms of object tracking, then I mentioned sort earlier. This is how that works, along with the bird's eye view. So we pick up bounding boxes across frames. The next thing then is we link them using the sort algorithm, which uses a Kalman filter and uses kind of IOU thresholds to figure out if a person is the same across frames. And then finally projecting that into the bird's eye view, we were able to look at things like distance traveled, the speed of the pedestrian, how long they spent in an area, as well as social distancing metrics as well. So all coming together, this is what it looked like. And see here the person with the buggy struggles to pick her out, but for the most part the model worked quite well and picked people up as they walked across the frame, and picked multiple people up as they walked across the frame as well. So I'll pass over to Eoghan now, who's going to talk about data collection.
Yeah, thanks, Ciaran. I think we've got a really good overview there of the processing. So I suppose the next step in our 4-step pipeline is the data collection. And where this differs compared to previous projects that we might have worked on or you might have worked on, such as a Kaggle competition, is that the data set is constantly changing. And we're actually in production. So we're going from kind of a static environment where your data set is in a zip file and that's it, to an environment where your data is constantly changing. And we needed to look at ways to adapt to that and ensure that our production system would run. So this is actually an image from a paper from Google. And what it looks at is the technical debt associated with production projects in artificial intelligence. So you can see there right in the middle, there's a really small little block where it says ML code. So the way we thought about this was the data processing that we just looked at was our secret sauce. So that was kind of where we had to put a lot of our effort to get the detection algorithms working really well and to get the benefits of that. But surrounding that was a lot of extra work in terms of getting the data up to the cloud, analyzing that, logging, serving the infrastructure, and monitoring. So we took on board the advice of that paper, and we built kind of a suite of tools around our ML code to allow our project to work seamlessly in a production environment. So this is actually our stack. So the Deepseek processing stack. So you can see there in red, the SageMaker endpoint correlates to the little ML piece of code that we had in the previous image. So if we go through this, first of all, in the data ingestion engine, we had to get the frames up and into the cloud. So to do this, we used a cluster approach using a tool called Fargate, where we could scale our servers to be able to handle that incoming load, no matter how many cameras were streaming to it. So by having that kind of cluster-based approach, we were able to scale and run as many as we needed to. So once that decoding had happened, we passed it to the SageMaker endpoint. And this is where our data processing ran. So the detections were generated in this point and passed to a Kinesis data stream. And this data stream could be as narrow or as wide as needed. At that point, the detection boxes that were generated on the SageMaker endpoint were passed to an inference output Lambda. So we used Lambda code, which is a serverless piece of code where you're charged only for the runtime. And this was really helpful in terms of reducing costs and scaling the application as well. So the inference output just got everything in a row, made sure that it was able to be saved to the detections database so that we could improve our models over time. And from the detections database, we ran the insights generator. So that's another Lambda. And what was running in that was the sort algorithm and the 2D projection code. So that just ran on an interval as well as a piece of Lambda code. So underneath the left-hand side, we see another set of tools that were used to stand up this production environment. So we used a tool called EasySM Deploy. And the reason we used that was because we were lucky enough to have hardware where we could train our YOLO models locally. So we have a desktop rig with GPUs, and that was a massive cost saver for us. And using EasySM Deploy, you were able to take the generated binary files, so the PT file in our case from PyTorch, and inject that straight into AWS very easily. We also used a stack creation script with CloudFormation, and that allowed us to just have our infrastructure as code. So everything you see there was actually marked up in code and was able to be spun up really easily. The MySQL database sat in the middle. So as we spoke about just the insights generator, once we had generated those high-level insights, we were able to store them in a MySQL database, and that hooked into a backend API, which was basically in charge of processing that database and serving it to the end stakeholders. So as you see on the bottom there, through a front end to the general public in a graphical user interface, and also some automated reporting for the council stakeholders. Another interesting point was we used OpenAPI to generate SDKs for researchers. So in essence, the whole stack was set up in a fashion that it was reliable and scalable and easily used to disseminate the information that the production system generated. So these are just some nuggets of wisdom in building a production system in AI, and mainly around the kind of the AWS stack as well. So on the left-hand side, there's a tool called AWS Lambda Power Tuning. So interestingly enough, with Lambdas, the memory allocation you assign to them dictates the processing speed. And there's actually a sweet point where you're getting your most bang for buck with these Lambdas. So essentially, the power tuning tool, you give it the ID of your Lambda, and it averages the runtime over a set number of runs. So we chose 10 runs, and it finds the optimal sweet point for running that on a cost-effective basis. So definitely something to check out if you're using Lambdas in your cloud. We use Docker across the board. And the reason for doing this is it encapsulates your code, and it can run anywhere. So once we had deployed our pieces of code into a Docker container, we knew that they were stamped and ready to go. And therefore, in our production environment, we never had a piece of dev code that was broken. So that really improved our process for making sure that the production system was always working. We use a tool called Flyway as well for the database. That allows you to version control your database over time. So when we added new features and new insights, we were able to run the Flyway tool into our production database and version control the database that way. And I also talked about EasySM deploy, which allows you to train your models locally if you have the hardware to do so, and really easily get them into your cloud environment in AWS. So those are just some nuggets of wisdom if you're building out one of these systems. So yeah, on data distribution then, it was really key for us that this wasn't a project that was very siloed and that the data was generated and stored on disk somewhere where nobody was able to reach it. So we looked at the stakeholders of this application, and we looked at the best ways to get the information to them. So this was really important in our backend. We used a technology called OpenAPI. And OpenAPI is kind of a set of tools that allows you to define your API, and from that definition, actually allows you to go ahead and generate SDKs in various different languages. So because we had developed our API this way, we were able to really easily spin out some SDKs. So we generated a Python SDK, an Aura SDK, and a JavaScript SDK. So from the bottom up, the JavaScript SDK was used in our front end. And for visualizations, the Aura code was used by Maths and Stats in the University of Limerick to analyze this data and start generating some predictions from it. And the Python SDK was also used for similar purposes and visualization. But in doing so this way, we were able to get the data in a queryable fashion into the hands of the people that could further this research and disseminate it in that way. So generating an API that can query your data is really important if you want people to interact with what you have generated. This was our public-facing dashboard. So we were also very conscious of not keeping the data just for researchers. We wanted the general public to be able to look at this as well. So we created a website where they could go to. We got a total of 14,000 views over the runtime of the project, and we were getting about 230 visitors a day. So that was an important point for us to keep the information in the public eye and allow them to also benefit from the data that was being generated.
So I suppose to sum up, I think Eoghan has brought us through the distribution nicely there, but this is just some of the insights that we looked at with the Maths and Stats department. So we looked at social distancing compliance across all of the streets we had our cameras installed on, and looked at it in correlation to the coronavirus cases as daily cases in Ireland. So what we found is using a 7-day rolling average is that as the cases went up, the social distancing compliance also seemed to follow. Now this doesn't mean causation, but it was a nice correlation and a nice, I suppose, thing to draw from the data. We also looked at heat mapping the Griffith Row data. So as I mentioned earlier, there's a cafe on the street, and the owner was really interested as to how many people use the street, but also why they use the street, because he was looking to put forward a proposal for pedestrianising the actual street. What we found here was on the left-hand side, bottom left there, you can see a lot of activity. That's where people going into the cafe queued mostly, so they queued up against the left wall. And on the top left of the image there, you can see there's actually a seating area as well as the door into the cafe. So we're able to show this data and present it and basically say that, look, people were using the street mostly for the cafe. So thanks for listening. I really enjoyed presenting. And if you want to reach out on social or email, our details are there.
Thanks very much, everyone.
Guys, thank you so much. What I loved about that presentation was how practical it was. Like, you could show anybody in your family and they'd be thinking, that's really cool. And you take these things for granted every day, but the impact it can have is fantastic. On a technical question, how did you prevent yourself falling down a few different rabbit holes? Because the very nature of the work you were doing, I think it'd be probably quite easy to maybe over-engineer this or go off in different tangents.
I think that's a really good question, Mark. And I suppose rabbit holes are inevitable in these kind of projects. And I suppose from a learning perspective, they're really important. And they're really important for us for that reason. So throughout the project, there's hardware parts to it, there's software, there's cloud-based parts, and then there's the actual AI engineering and the data engineering. So particularly with the hardware, first of all, we fell down quite a few rabbit holes. I mentioned the heat earlier on. And then in terms of the cloud as well, and how we were actually training our models, fell into very similar rabbit holes. So I think the important thing there is to actually realize as early as you can that you're going down a rabbit hole, and trying to come back up and I suppose take a step back and say, okay, are we going in the right direction with this? And I suppose towards the end of the project, that's something that we got better at as we understood how the different components were coming together.
When you were doing it, did you make any pivots that you actually felt like this is a bigger problem that we should look to solve rather than a previous one?
Yeah, I don't know that we make too much pivots. I suppose on the technology level we would have, but I think we really had a clear goal of what we wanted from the outset. So we wanted to have a production system, as I mentioned, rather than something that is just internal. And we definitely wanted the data to be available to everyone. In terms of rabbit holes as well, I think that you can always improve the model, and you can kind of get to a point where you're saying, is this good enough to deploy to production? What percentage of accuracy will it have? But I think we learned a lot more from deploying it. So getting a kind of a near enough is good enough approach, and then iterating on that model in production. So I think that's kind of like a wider problem in AI research as well, that we're fascinated by benchmarks against test sets and things like that. But I think we're really going to crack some interesting stuff when we get it out there in the real world and we see how it does.
Yeah, I'd like to say thank you to Ciaran and Eoghan at Deepseek.ai for your time today. I really appreciate it.
Thanks very much, Mark.
Next, what we're going to have is Milton Luaces, and Milton is going to provide an insight into his experience working in FTI Consulting, where he's leading the data science practice at the moment. Milton used to lead the data science practice in Alexandra and also in onboard intelligence as well. So we're absolutely delighted to have Milton on our virtual meetup today.
Well, thank you very much for the introduction, Mark. And as you said, I'm leading the data science practice at FTI Consulting here in Ireland. And it's pretty across industries, but most of our clients at the moment are on the financial sector. And there's a lot of opportunities for data science in this field. We will discuss a little more about it. So about the FTI Consulting itself, I mean, it's pretty small company. It's less than 5,000 employees, but it's all across the world, different branches in the 5 continents. And actually, it's growing very fast. Last year, it was the fastest growing company in the financial sector in US, which is a huge achievement. And here in Europe as well, there's big growth of the company in different sectors. In particular, in Ireland, we have a well-established practice in business transformation, strategic communications, data engineering as well. And since last year, when I joined the company, and we are starting with this brand new data science practice to complement, in particular, the data engineering, but also the other practices. We had from several years in UK, in London, a well-established team in data science, and now we have these local capabilities in Ireland as well, which is good. Our approach when we go to market to our clients is mostly value-driven. That's why we wanted to discuss about how we can power the offerings with data science to bring more value to the business. So we definitely try to be up to date on the cutting edge techniques, because this field is changing every year and even every month with new techniques coming on or techniques that were existing once and are being improved and relaunched. This is good. So we want to be technology agnostic, and this is because our clients come from very different platforms and legacy systems and data warehouse and so on. So we typically do our work in Python, but also R, C#, Java, and of course, big data and cloud platforms. But the key point is that we want not only to deliver technical outcomes, but actionable outcomes from a business perspective that the clients can measure and can prove the value that we bring. And on that, there is a challenge that we have with many clients on the financial sector, that when we talk about this data science, they typically know about something similar, which is BI, business intelligence, which is close to data science, but data science is much more than that. So maybe they are used to gather data and do some cleansing and wrangling, and then preparing the data for fancy visualizations, even dynamic visualizations like dashboards. And all this is very helpful for them to make decisions for their plans on the business. But if we think that you are looking on the data and just having a good way of reporting, which could help to uncover any known patterns that you are looking for, but you will never uncover the unknowns. I mean, the things that you don't know specifically, but you don't even know the pattern that you are looking for. And this is one of the areas where data science can help and can show us patterns that never happened before, but are critical for the business. I mean, one of the reasons that BI is widely adopted is that the time and effort that you need to bring some value is shorter than data science. And also the risk is smaller. But of course, the value is correlated with that. I mean, typically you have a small value in a short-term period, and that could work for the business, but there are many reasons to go beyond that. When we think on business intelligence, that is basically descriptive analytics, reporting, visualization, and from there we can go to predictive analytics and also prescriptive analytics. So not only the predictions themselves, but also the actions that should be taken from those predictions. Clearly, the expertise needed for data science is much deeper than what we need for BI. This is one reason that people want to know if we deliver a data science solution, if they could have control on it, if it will have explainable or interpretable outcomes. And there are many things that can be done for that, and we are working hard to close to the business to provide as much as we can. And as I said at the very beginning, actionable outcomes, outcomes that they can understand, interpret, and apply. So, and of course, the objectives, the analytics, the methods are different, and the value, most of all, could be quite different. So, to give an example, some time ago, I had a project on churn analysis for a bank in UK, and they have done something on that with BI before, which basically here you can see an example. So different charts of churn rate by age, by revenue, and maybe better than this, you know, different charts showing the different churn rate on time, which is good for them to make some decisions on where are the pain points, or which are the right actions to take. With data science, we went beyond that. I mean, first doing some micro segmentation where we could have an idea, not the segmentation that the bank had for other purposes, but specifically for churn. So trying to identify the behavior of customers and group together the customers that have on time and similar behavior on their accounts. And then we built their predictive model for scoring the propensity for churn. So, and then we can apply that to each specific microsegment. This could be much more insights for the business than just statistical analysis. Another example, if we are thinking on anomaly detection, we could do something with BI, you know, to report the fraud cases investigated, or by geography, by demographics, and that could give an idea on the rate of fraud in different with different features coming from the clients. But with data science, we could do more than that. Unfortunately, on fraud, the patterns are changing all the time. So the fraudists are ahead of us on that. And it's quite difficult to even know what we should look for. So last year, for instance, I was a co-author of a paper, and it was published, you can check on the internet, by anomaly detection in networks. So there we applied graph analysis with machine learning and autoencoders to detect what is new pattern unknown for anomaly detection. So there could be many examples like that, where data science can uncover unknown patterns, which definitely has value for the business. And to give a recent example, this is on one of our clients in US. It's a financial company specialized on loans for particular leisure, particular purposes. And they had a huge variation on the propensity of their clients to go into arrears or even delinquency since the COVID started in US, which is expected. But the point is, the models that they had at the moment, so simple statistical models on forecasting, couldn't be adapted for the new situation because it's completely new. It never happened in the past. So there's no way to train the models or to reparameterize existing models so that they can continue predicting with a decent accuracy what is happening right now. So we apply a different approach, which is called touchless forecasting. We'll talk about that. Basically, it's embedded into the modeling, the whole process end to end, from all the data that we have available, internal and external data. And so all the steps that we typically do as data scientists, embedded so it can be dynamically recalculated, even the features that we bring into the model. So in this case, we apply, of course, correlation analysis, but also dependence analysis, which is not the same, and importance analysis, sensitivity analysis. So all those are possible to be embedded into the process. So at the end, at the very beginning, you have many features, internal, of course, demographics of the client and the transactions, and the history on the account and on other accounts, and also scoring, risk scoring from FICO and other data that we have available. But we also had external data, in particular related with the COVID. I mean, in US, it is publicly available, all the data related with the COVID state by state, and in some cases city by city, related to how many people get the COVID, and sadly how many died, and the number of tests carried out in each of the states to check how reliable is the data. And all that is available. And also some other figures that are related to the COVID, like unemployment rates and subsidies state by state, which can influence the possibility of the clients or of repayment of their loans. We embed all these features and do all this analysis as part of the model. And at the end, we end with a few features, a golden feature set, where we can apply some cutting-edge techniques on forecasting. And one of them that was really successful here was LSTM. So is this deep learning neural networks, long-term, short-term. So these models are capable to remember from the most recent data, most relevant, but also some relevant data from the far in the past, and adding external data in these models from the COVID figures that we have available. So with that, we were able to provide decent modeling on the forecast of the propensity of the clients to go into arrears or to go into delinquency. And more important than that, we could check that each week this model can improve with new data. Actually, very recently, we delivered a project for public sector here in Ireland, also applying this forecasting with the external predictors, 3 or 4 different ones. And clearly, as I said before, these models can improve on time and self-adapt. That is the key point on touchless forecasting. So the point is, when we have conversations with the C-suite on the business, especially on the financial sector, we as data scientists can identify many areas where we can improve, or gaps, or where we can solve problems or optimize processes. But the key point is where the value is big enough so that the people on the other side, from a business perspective, they can have an appetite to invest and to go more in deep on data science. I think that is a key factor for us to succeed on the applying data science, and definitely will help us to add more value to the business. So this is just a flavor that we wanted to give on our activities, data science, FTI, and the way we approach on our clients to add value.
Milton, thank you very much for that. That was excellent. Really, really helpful. It was great to see the difference between business intelligence and data science. I have a couple of follow-up questions. First question would be, how do you manage expectations with the C-suite in terms of the journey that you need to go on to really maximize the data that people have? Because there's a lot of transformation that actually happens. And then also, the reality is that the high number of data science projects don't generate the return on investment that you would hope for. And there's a variety of different factors on that. But I'd love to get your experience over the years from working in this field on that.
Yeah, it's a very important point that you mentioned. Well, actually, I think we as data scientists should think strategically and help our clients to see this from a strategical viewpoint. Because typically, the clients want to solve a particular problem, very tactical. We are reactive for that and go offer a solution, you know. And most of the time, I had to admit that it could be a little bit quick and dirty, you know, just deliver something that solves a problem. They get some pocket money from this small project, we go to the next. Well, instead of doing that, I think it's really important to give them the roadmap that they could have in a particular division on data science, with which are the steps that we recommend that would be good to take to improve their business, and then start with the different more tactical steps on POCs, and make clear that when we talk about a proof of concept or a proof of value, it will prove that the value is there, but the value won't be effective until you deploy and productionize the solution. And that will take more investment from the client. They should be aware of that. Otherwise, as you said, they could have expectation on having things into production in a couple of months, and then get disappointed and POC is going nowhere. We have to be very clear on the different phases that a data science solution has, and also have some checks on feasibility on each point, so that we avoid that our clients are investing if we are not completely clear that they will get the value they expect.
Milton, which industry is the most exciting to you at the moment in terms of the application of AI? Because you've worked in a variety of different industries. Is there one in particular that gives you the most excitement?
Yeah, I should say that there are two industries that are changing dramatically at the moment. So I've been working a lot on both. First, on financial sector, because there's a change that is taking place right now, mostly due to the fintechs and many startups working with mobile devices, edge computing, combined with cloud computing, and so on. And not only, but also the traditional banks are moving to these new technologies. And that is a great opportunity for us to rethink how will be the banking in the next 10 years. And there are a lot of opportunities on leveraging the data that is available, which is much more than before, from their clients, on how they use the devices, how they interact, and even there's a lot of opportunities coming from unstructured data, like communications with the customer service, or phone calls. All that can be passed to text, and from text to data science, NLP, natural language processing modeling, and we can enrich the models that we had in the past for a better customer experience and result for the business as well. A second one is on pharma sector, which is exploding right now, as we know. I had several projects in the past, and we are pitching right now with the very big players in the field, because they are investing more and more on R&D with data science, even for instance for vaccines, to help them on search on the right antigens and adjuvants for the vaccines, and data science can do a lot. And the same in data quality assurance and consumer marketing as well. We are helping. I think these are the two most exciting sectors at the moment.
Milton Luaces, MD, FTI Consulting, really appreciate your time today. I'm now going to